Okay, before I start, good afternoon, everyone. So I want you guys to be aware that actually I have included a section in your Putra Blast. So near the mini project 5%, which is due on 23rd September. This is a group project. This is where you submit the article. So if you click on it, it says ada 23 days and 9 hours to go. So that is due on 23rd September. And then this is the link. This is the link to submit your video. You just upload it into this link. Yeah. Okay. Okay. So this is the link where you submit the video. The video should not exceed 3 minutes. So upload MP4 lah. Okay, MP4 version of your video. And then this is your lab video assignment. Okay, I think some of you macam tak sure about this. So basically your class is divided into several groups, lab groups, right? So this lab groups, kita ada 12 kot lab groups. So seven groups will be doing the lab 2 video, and the other 7 groups will be doing the lab 4 video. Since we have already completed lab 2, so I am expecting you guys yang assigned to do lab 2 to work on your video as well lah. For lab 4, boleh tunggu sehingga lab 4 comes, which is in 3 weeks. And the groups that need to do lab 2 video is, if you click on it, dah ada nama kat sini, the groups that are assigned to do lab 2 video. And then the groups to do lab 4 video are these groups. Okay, so I just divided into 2 lah. And I have not specified a deadline yet, but it would be nice if you guys would start on it before like the deadline and then kelam kabut semua kan. So just start on it. You just have to make a less than 3-minute video. Okay. Apa lagi nak cerita? So lab video, and then you have your mini project. And again, mini project can be anything that you have learned in semester 1 and you feel like it relates to your daily life. Macam projectile motion, you can talk about the basketball, or if you want to talk about apa nama dia? Cycling, which is related to centripetal acceleration and centripetal force in chapter 6 later. So you can. But we haven't learned that. But if you want to do that, boleh. Walaupun kita tak belajar lagi. Boleh Okay, and then I think that's it. Alright, so let me continue. Oh, ada check kat sini. Bahasa English ke Malay, Miss? Haikal, which one are you referring to? Is it the mini project article or your video? Kalau video is
mini project.
Article.
Okay, tapi kan artikel dengan video sekali kan?
Artikel dengan video sekali. The video should be related to your article. If you want to do your article in Malay or English, boleh dua-dua. But I prefer English sebab nanti kita nak semak plagiarism, and preferably in English lah. But if you are not comfortable doing the article in English, you can do it in Malay. We make sure tak tiru siapa-siapa lah. Jangan tiru artikel orang lain. Make sure it's your own original writing. It doesn't have to be original idea. It has to be your original writing. Contohnya, awak baca artikel and you really like that article, olah that article in your own words. Okay, do not copy the article. And make sure you understand lah, because I will ask you on what you've explained in the article. So make sure you really understand and you really like what you're writing and what you're recording later. Okay. For the videos, semua kena English. Artikel sahaja ada pilihan Malay and English. Artikel sahaja. And then the best article will go for, kita akan select, kita akan masukkan dalam conference. Okay, so those are for the best articles. It doesn't matter if it's Malay or English, preferably English. Okay, itu saja. Tak ada soalan dah Okay. Let's continue with our class. So I'm going to share. Template untuk artikel pun dah ada. You don't have to write a lot. It's just like three quarters of a page. So it's quite simple and you can put in your own picture that you take. Ambil sendirilah gambar tu, jangan curi gambar orang lain, okay? Basically that's it, don't plagiarize. Plagiarize means copying. Okay, stop sharing this one. Let me, it's an individual work. No, all of it, you have to do it in lab groups. Semua dalam lab groups. Okay. Untuk lab memang dalam lab group lah. Untuk submission article semua tu, I think I am accepting lab group or individual. So some of you want to do it yourself, I think, for the articles and the video. So I allow that. But for the lab video, kena buat dalam lab group. Is that okay with everyone? Kalau mini project tu, I give permission for you to do individually. Ke ada bantahan? Tak ada bantahan? So everyone doesn't know what you guys want? Okay, alright. So Atira said okay on behalf of everyone. So everyone else is like don't know. Saya follow je. Okay. So boleh buat dalam lab group ataupun individual. Okay, kalau rasa macam bersemangat nak buat seorang-seorang boleh. I allow that. Okay, let me share. What was I going to share? Okay, presentation. All right. So let's continue with our second last part, which is projectile motion. And then after projectile motion, kita akan deal with graphs of motions. So kita last time we stopped at this one. Okay, this problem, we did this one. So an artillery rocket is fired with an initial velocity of 300. Kita dah buat ni. Kita kebal rocket. Okay. So this was the problem that we did last time. An artillery rocket or kita kebal, whatever. I don't know if it's kita kebal or what, but basically it launches something lah. It's fired with an initial velocity of 300. So this is our U naught or V naught, 300 at 55 degrees above the horizontal. So 55 degrees above the x-axis. It explodes on a mountainside 42 seconds after firing. So the total duration before the total duration of the motion is actually 42 seconds. Kenapa dia jadi total duration? Because this is where the motion ends. So 42 seconds is your total time before the motion ends lah. Okay, so determine both the horizontal and vertical displacement. It wanted to know Sx and Sy where it explodes. So this refers to time 42 seconds. So you need to find your displacement with time 42 seconds relative to its firing point. So if it's saying relative to its firing point, tempat yang dia shoot ni will be considered as 0, 0 coordinate. Okay, let me write it here, 0, 0 coordinate. So it's up there. Relative to its firing point, kat mana dia fire, this is where it's firing. So this is your reference point, 0, 0. And then it shoots and then lands on a mountainside. So how do we know that it's above the critical baldo? Because it's a mountain and you are on level ground. So this is our assumption. Okay, so for the displacement, we used S equals to UT plus 1 over 2 AT squared. Actually, I already got rid of our calculation. So let's just go over the schema je lah. Mana dia? Okay, it's this one. So for the horizontal displacement, macam biasa kita ada X and Y. This is our X. They solve for S first. And they use U cosine theta T. So dapat sama, basically sama apa yang kita dapat last time. It was exactly the same. And for the angle, kat sini your Vy is actually a minus. Okay, mana Vy? So Vy is actually a minus. So kat sini skema ni patutnya inverse tangent minus 1.66 times 10 to the 2 over Vx. Your Vx is just Ux, so that is 1.72 times 10 to the 2. So you will get a negative angle, which is 43.98. Tapi kat sini dia tak pakai the negative sign, so you don't know that your angle is actually negative. So please do not forget the signs. You will get the negative sign here. Therefore, you will know that your V with respect to the x-axis is 43.98 degrees. So this is your V. This is your Vx and this is your Vy. Okay, your Vy ke bawah, Vx ke kanan, positif. This is your vector velocity yang dah gabung Vx dengan Vy. Okay, what else? So this is the magnitude. So this is straightforward. 1.72 times 10 to the 2 tambah minus 1.66 times 10 to the 2 squared, square root the whole thing. For magnitude, this is the sign here, but we usually don't write it. You only want the magnitude, the plus minus tak ada, walaupun square root. We only want the magnitude when we are using Pythagoras theorem. There's no positive or negative when we are talking about magnitude. Magnitude means value, no positive, no negative. The direction is given by this equation. We don't want the direction from the Pythagoras theorem, so don't make that mistake of putting positive ke negative, don't. And then apa lagi saya nak cerita kat sini? I think everything else is quite straightforward. Kita dapat time, so it was quite an easy question lah sepatutnya. Okay, so the next question. A man stands at the edge of a cliff. Okay, so we have a cliff. Okay, this is our cliff. And there's a man over here. Who should the man be? We don't know. It's a secret. And dia duduk kat sini. The cliff is 50 meters above the ground. Okay, this is 50 meters above the ground. And he throws a stone horizontally over the edge. He throws a stone horizontally, maksudnya on the x-axis. So V0 is equal to 18 meter per second. The cliff is 50 meter above ground, and with respect to the ground, we can say this is 0, 0, and the guy is at coordinate 0, 50. This is x, this is y. The x is basically the same, right? Orang ni ataupun the man is 0, 50 coordinate and the ground level is 0, 0. And V0 is 18 meter per second. So now we have to know what is our Ux and what is our Uy. Okay, can anyone tell me how to find the Ux and the Uy from this question? Anyone wants to try? So kita ada chat. Okay. Ux, anyone? What's my Ux here? So semua takut nak jawab. Okay, so I have one chat here. Yanni Sio. Yanni is Feli ke Yan? Saya sampai sekarang confused lagi, sorry. Is it E? It's Feli. Okay, Yanni Sio is Feli. Okay, so Feli jawab the Ux is 18. It is correct. Macam mana tahu 18? Macam mana tahu 18? Because if we look at this V0, what is the angle with respect to the x-axis? So this is our imaginary line. The angle with respect to the x-axis is basically 0 degrees, right? So if we wanted to use the equation, we could. So it would be 18 cosine 0 and the Uy would be 18 sine 0. So a cosine of 0 gives us 1 and a sine of 0 gives us 0. So this would give us 18 and 0. So our Ux is 18 and our Uy is 0. Okay, so Feli is correct. And then the question, now we go to the question. How long after being released, maksudnya lepas dibaling tu, how long does it take to strike the ground below the cliff? So the stone is obviously, so the stone that is thrown goes over a projectile motion. and hits the ground below the cliff. So immediately we know that the displacement is going down, right? With what speed and angle, so this is asking for time, total duration, with what speed and angle of impact does it land? So it's asking you what is the magnitude of V and theta of V. Walaupun dia cakap pasal speed, but when we talk about the magnitude of velocity, we are actually talking about speed. So it's the same thing lah. Basically, you have to solve for velocity. And to solve for velocity, you need to know what is your Vx and Vy. Okay. So again, let's use our table. So this is my table. Kita buat teruslah. Okay, so sorry. So kita write our X and Y. It's not a good color. Okay, so Ux is 18 and our Uy is 0. So our Vx is supposed to be the same at all points. So Ux are equal to 18 and Vy we don't know yet. And we are looking for the time and we are looking for, we're not looking for the displacement, but we should put it here because kita nak tahu all information. So Sx we don't know, Sy is supposed to be Y final minus Y initial, and the final is 0 minus 50. So the S is equal to minus 50 meters. So this is the displacement in the Y. So those are your information that you have so far. Did I miss anything? Tak ada. Okay. So how should I find my time or Vy? What should I do here? V squared equals to U squared plus 2AS. We can use this equation. V squared U squared plus 2AS. Let's use this equation. And we don't know what our V is yet. And our U is 0. And this is 2, 9.81. Sorry, this is a positive, minus 9.81. And this is a minus 50. So this would give me 2 times minus 9.81 times minus 50. So you get 981, square root that, and it should be 31.32. What should be the sign of my Vy? What should be the sign? Is it a positive or a negative?
Negatif.
Okay, negative. Sebab kalau kita tengok kat sini, this is the way that the stone is being thrown. So our Vy is going down and our Vx is to the right. Okay, remember your components should be sandwiching your velocity vector. So Vx to the right and Vy going downward. So your Vy here should have a negative sign. Now my question is, where did we get this negative sign? I know it's from here, but mathematically, where did we get it?
Punca kuasa.
Punca kuasa, okay. Saja nak test korang, ingat lagi ke tak? So when from our square root of 981 tadi, B squared is 981. So punca kuasa of 981 gives us a positive, plus minus answer. Plus minus answer 31.32. So macam mana kita nak tentukan? Tengok diagram, draw our components, and from here, from this diagram, we know that the Vy should be negative. So you pick the negative sign. Okay, I'm repeating myself here. Walaupun kita dah ulang banyak-banyak kali, harapnya semua orang ingat. Okay, this is a negative. Look at your diagram, determine the sign. So that is your Vy. So from your Vy, what else can we get? Can we get the time? What equation should we use? So equation number V equals to U plus AT. Sophia said V equals to U plus AT. So let's try that. V equals to, oh sorry, kita nak buat dalam Y kan? So V equals to U plus AT. if I'm using the values in the Y component, then semua orang kena pakai Y component. So this would be V minus 31.32 and our U is a 0 plus minus 9.81 and the time would be, we don't know yet, and that would be minus, betul ke ni? P equals to U plus 80, okay. Minus 31.32 divided by 9. So I get 3.192. Is that what you guys got?
Yes.
Okay. 3.19 lah, 2 decimal places. Boleh kalau nak letak 3.193 ataupun 3.1927 boleh. Lagi tepat lah, but just use 2 decimal places kalau malas macam saya. But at least 2 decimal places. Kalau malas pun 2 decimal places, jangan malas lebih dari 2. So you get 3.19 seconds. Okay, so how do I find the time for my X? What should be the time for my X here?
Same.
The same. Tak boleh lain When we are talking about time, if the time taken to reach this point is 3.19, then in the x-axis juga, it's 3.19. Dia tak boleh lain. So I think last time ada orang confused about this. They use the equation to solve. If you already got the time from the y-axis, from the y component, it's the same for the x component as well. Doesn't change. Okay, and then for Sx, if we wanted to know, we could. It's just u times t plus 1 over 2 at squared. This guy becomes a 0. Okay, so you just left with ut. So u is 18 and then 3.19. But the question didn't ask us for this one, so we don't have to solve for that. So we already know what is our Vy and what is our Vx and the time. So basically kita dah tahu dah lah jawapan. We just have to complete this last part, which is the velocity. And at this point, saya rasa macam equation Pythagoras theorem ni dah basi. Kalau tak tahu lagi, tak tahulah. So V equals to, Vx is 18 squared plus minus of 31.32 squared. This is a 3. And then square root. And again, when you are finding velocity, you are only concerned about its magnitude or its value. There's no positive, negative, walaupun punca kuasa. So I don't know what that is. And then for the theta, it's simply tangent, inverse tangent of minus 31.32 over 18. So you would get a negative angle, which is below the x-axis. If you're not sure about this, okay, look at your values here. Your Vx is a positive, so your Vx should be this way, and your Vy is a negative, so your Vy should be this way. Therefore, your velocity vector should be in between the Vx and the Vy. So it should be below the x-axis. This is if you are not sure if it's below or above the x-axis. So you can draw it and look for it. Tapi kena Vx dengan Vy tu kena betul lah. Kalau salah, salah lah juga. Okay, so that is that. I think it's quite straightforward at this point. So kita dapat 3.19 and for the speed it's 36.1 and for the angle it's 60.09 below the x-axis. Okay, now we go into the, oh, I have 6 chats here. Sama. Okay. Okay, now we go on to the, okay, before that, does anyone have any questions about the example that we did just now?
Doktor, saya nak tanya, time untuk X component dengan Y component untuk semua jenis projectile motion sama ke?
Sama.
Saya doktor.
Faham ke tak kenapa sama? Hello.
Sebab kalau, contoh kalau time untuk up sama dengan time down lah, kan? Itu sebab dia.
Time to up sama dengan time, and tu untuk free fall. Okay, saya cerita lah, okay? Saya cerita balik pasal time. Okay, let's do this one. New slide. Okay, tadi kita cakap pasal ada orang tu dia baling apa nama dia? stone. Let's copy this diagram. Okay. I have one chat here. Let me see. X Afifah. Okay. Tante Afifah tak ada X pun. Pandai je kan. Okay. Kesian Afifah. Kena fitnah. Okay. Kita nak cakap pasal time tadi. Okay. So kita dapat time dekat sini to reach the Y displacement, right? The time that we saw for the Y component was 3.19 seconds, right? Okay, so we got to reach from here to here. Okay, this is our Y punya value. This is our SY. To reach from 50 down to 0 or to reach minus 50 displacement, the time taken is 3.19 seconds. Okay. Batu ni dia go over a projectile motion. Dalam y-axis dia menurun macam ni. Dalam x-axis dia ke kanan. Okay. Saya tahu stone ni dia projectile motion dia macam ni. Tapi kalau kita nak bayangkan dia punya y dengan x komponen, y dia menurun, x dia ke kanan. Baru kita dapat sampai ke sini. Betul tak? So our SY is a negative, our SX is a positive. So that is just the displacement. To reach SY of minus 50 is the same time to reach SX of, don't know, what did we solve it? 18 times 3.19. Berapa entah? 3.19. 57.42. So dapat kat sini 57.42. So untuk projectile motion ni, koordinat terakhir dia adalah 57.420. This and the time taken for the stone to go from 0.50 to 57.420 is 3.19 seconds. This is referring to both the Y and the X. Boleh ke kalau batu tu jatuh je tapi dia tak ke kanan? Tak boleh kan, sebab ni is projectile motion. Sambil dia jatuh, sambil dia ke kanan. So bila dia sampai kat sini, ke bawah, dia juga ke kanan. Dan masa untuk sampai kat point ni adalah sama untuk X dengan Y. Does that make sense?
Faham Dr. Faham?
Faham Okay, another example. Kalau saya cakap, what is the displacement in the X and the displacement in the Y? Okay, what is the displacement in the X and the displacement in the Y at time 2 seconds? Contoh, what is the displacement in the X and what is the displacement in the Y at 2 seconds? So, contohnya dekat 2 seconds, dia tunjuk kat sini. Dia tunjuk kat sini. Ni soalan yang saya reka-reka. So at time 2 second, dia reach at this point. So I want to know what is the displacement in the X and what is the displacement in the Y. So I need to know berapa banyak SX yang dah sampai ke sini and berapa banyak yang dia dah turun. Sebab dia turun daripada sini kan, dia turun daripada sini. So dia turun sebanyak sikit je and SX dia sebanyak ni. So cara nak cari at time 2 seconds So SX equals to UT plus 1 over 2 AT squared and our X component for acceleration is 0. This gives us U of 18 times 2 second which is 36 meter. So dalam SX selama 2 saat dia dah ke kanan sebanyak 36 meter. Okay, so now kita nak tahu berapa banyak dia dah ke bawah dalam masa 2 saat. Sebab dia sampai kat sini. Dia ke bawah dan juga dia ke kanan. Kan, dia macam tu kan, baru dia sampai sini kan. So SY adalah UT plus 1 over 2 AT squared. Is that an easier one to use? Tak ada kot. Okay, so U is 0 plus 1 over 2 minus 9.81 and this would be 2. So immediately you already know that this is squared. So 2 times 9.81, 2 times 9.81 is minus 90.62. So at this point, dia dah ke bawah sebanyak 19.62 of in the y-axis. Okay, and masa untuk sampai ke bawah 19.62 tu adalah 2 second. Masa untuk ke kanan sebanyak 36 meter adalah 2 second. They refer to the same point, which is this point. Okay, so when I solve for 3.19 second for the y, I'm actually solving 3.19 second for the total SX as well. Okay, I hope everyone is clear on this part. Any other questions? Kejap saya baca chat. Clean and clear. Okay. Kenapa nak hadiah doktor? Tak faham. Tak faham kenapa. Okay. Okay, Haika is saying, I don't know what that emoji means. Means happy, good. Okay. Moving on to the next subtopic. I hope there's no other questions. Ke ada? Kalau ada boleh tanya sekarang. Kalau tak ada kita move on. 1, 2, 3. Tak ada. Okay. So next subtopic. So now we're talking about graphs. Our motion can be described in terms of graph because basically motion ni boleh quantified in terms of displacement, in terms of velocity, in terms of acceleration, and we can plot these into graphs. So for this example, this is a displacement time graph. If you are required to draw a graph, please label this penuh-penuh. If you know that you are talking about displacement, write displacement x meter. Kalau letak displacement dalam kurungan meter saja pun okay, you don't need the x. And then for this guy should be time t seconds. Okay, tulis penuh-penuh dia punya labeling. Okay, so from the information that we can get from this graph is actually the displacement. Directly kita tengok graph ni kita boleh tahu what is the displacement and the average velocity and also the instantaneous velocity. So sekarang ni kita kena go back to our first subtopic of this chapter, which is average velocity and instantaneous velocity. Okay, so for displacement, my question goes, what is the displacement of Ali at time 30? So I can just look at this graph. This is time 30. So the displacement of Ali at this time is basically 0, or basically Ali is back to the reference point. Or 0 lah, 0. Reference point dia start dari sini pula. Tak tahulah. So dia start dekat 30. Dia tak start dekat kosong. So, okay, never mind. So this with respect to A, it is minus 30. Okay, kalau kita tengok graph ni je, we just say at time 30, the displacement of Ali is 0. Dah, straightforward. Dia tak tanya benda lain kan? So that is your answer lah. Okay, so now, what if they ask you, what is the displacement of Ali at time 10? So look at this graph. At time 10, this is the displacement. I'm looking at this point. This point tells me it's 55 meters. So Ali is at 55 meters. Kita tak tahu dia with respect to apa sekarang ni. We just know from this graph that this displacement is 55 meters. Okay. Lepas tu, so that is displacement. And then we talk about average velocity. We can actually get average velocity from the displacement graph. And if you guys still remember, the average velocity equation is delta x over delta t, or the change in displacement over the change in time. In this case, the change in displacement is your y-axis, the change in time is your x-axis. But for average velocity, you actually have to know what is the final minus the initial over the t final minus t initial. By this, I mean final yang final betul-betul tak ada section. You have to take the actual final coordinate and also the initial coordinate. So in this case, our coordinate for the final and the initial, let's write it down. So coordinate untuk F is 50 in the X, and also, what is this? minus 50 lah kot. Minus 50 in the y. So this is your final coordinate, x and y. And this is your initial coordinate, which is 30. Sorry, that is a 0 for the x and 30 for the y. Assuming lah. So dalam equation average velocity ni, kita kena pakai these values. So kalau nak bayangkan kita ambil this line from here to here. So this is what we're trying to find, the gradient of this line. Draw. So we are trying to find the gradient of this line, basically. The line is connecting the initial to the final because this is the equation for average velocity. So if I were to use this coordinates in my equation, so that would be, this is y over x, right? Minus 50 over, sorry, minus 30. The x is 50 and the x over here is 0. So I would get minus 80 over 50. Therefore, my velocity is minus 1.6. So this is the answer, meter per second. How do I know it's meter per second? Because displacement is meter and time is in seconds. So you get your answer as meter per second. Why is it a negative? Because your slope, your gradient of this line connecting the initial and the final displacement is a negative. It's going this way, right? It's going down. Therefore, your m is a negative. Negative 1 block. Negative lah, negative 1.6. Okay, so your m is minus 1.6. Therefore, we can conclude that from the displacement graph, the gradient is referring to the velocity. Kalau kita connect the line between A and F, we would get the average velocity. Because why? Average velocity is about the total duration. Now, what about instantaneous velocity? If I wanted to know what is the instantaneous velocity at point B, let's say, okay, I would have to draw a graph like this. And for point C, a graph like this, sorry, a line like that. And for point D this way, and for E this way. And if you look at these lines, the gradient are not necessarily the same. And then this gradient is m equals to 0. If m is equal to 0, then your instantaneous velocity is also equal to 0. Because the gradient of this graph gives you velocity, right? And for this guy, the velocity is minus. Velocity is minus. And also this guy is minus. But if I wanted to talk about the instantaneous velocity at this point, this guy has a positive gradient. Positive, therefore the velocity is also positive. Okay. To recap what I've talked so far, average velocity kena connect the line between the initial and the final points. The gradient of this line gives you the average velocity. For instantaneous, what is the definition of instantaneous? It is the velocity over a shorter duration of time, and we are referring to the shorter duration of time lah. So this takes a shorter time. Let's see. It's from here to here. That is your shorter duration of time. For D, we can take from here to here. That is your velocity at this duration of time. Okay, so and in this case, it's from 9 to 12, let's say. So this is the duration of time. It has to be shorter than the total duration to be considered as instantaneous velocity. Okay, so now let's see how to calculate instantaneous velocity. Kita padam balik. Kalau soalan boleh tanya. So I hope everyone is clear on finding average velocity. Oops. Okay, average velocity. Okay, clear. Number of solution equals to 3. Apa maksudnya ya? Okay, so untuk instantaneous velocity, let's say kita nak cari instantaneous velocity at point B. Kalau kita tengok kat sini, value dekat B, coordinate daripada sini ke sini kita nak tahu apa coordinate dia. So coordinate dia, let's say let's say it's 9, and this is 52, and this point is 12 in the x-axis, 12 in seconds, and also 52. So kalau saya nak cari instantaneous velocity for this guy over here, so it's v equals to v final minus v initial over t final over, it's displacement. X final over X initial over T final minus T initial, specifically for these 2 points. Okay, these are your initial and final for instantaneous. So X final 12, displacement is 52 minus 52 over T final is 12 minus 9. So here we can say that 52 minus 52 is 0 over 3, so which is a 0. So you can see that a straight line gradient gives you a 0 gradient or a 0 velocity. Is this familiar? Does this look familiar to you? V equals to 0.
Yes.
Yes. What is it?
It means that it moves but in zero. No. Pertambahan dalam velocity lah.
Okay, tak ada pertambahan dalam velocity. Okay, betul. But is this familiar from what we have learned so far? Kemana kita nampak V equals to 0 ni?
Dekat free fall bahagian atas sekali.
Free fall dengan bahagian atas sekali. Betul? Ada lagi tak tempat yang kita nampak?
Maximum height.
Maximum height for projectile and also for free fall. So this was for free fall, and for projectile motion, we also had V equals to 0 at this point. And if you look over here, this is also the maximum height. Maximum height lah. So V equals 0. Yang paling tinggi kat sini, this is the maximum displacement of this object, which is 52 meter. Okay, so this is where the V equals to 0 comes from. It is the gradient of that displacement. Okay, so I hope everyone is clear on this one so far. Okay, instantaneous, right? Another example of instantaneous, let's talk about D. Okay, so if the question asks, what is the instantaneous velocity from time 25 seconds to 32 seconds, contoh. It's asking for the instantaneous velocity from time 25 to 32. So time 25 is approximately over here, and 32 is here. So I connect these 2 points together by a line. So you can use your ruler. I'm using my shape here because I don't have a ruler for this guy. So kalau nak tebalkan, it would, jangan jauh sangat. It would look, kenapa pakai yang tu? Let's use green. Okay, so that is my line. So whatever gradient that I get for this line, that would be my instantaneous velocity for time 25 seconds to 32 seconds. So now I need to know what is the coordinate. So this is 32 for the X, and the coordinate for Y is minus 10, let's say. And for this guy, the coordinate is 25 because that is where the question specified. And for the Y coordinate, it's, I don't know, it's 18 maybe. Okay, these are just assumptions, not necessarily precise. So to find the instantaneous velocity based on the question, which is 25 to 32 seconds, so V equals to the change in the y-axis over the change in time, or the change in the change in the displacement over the change in time. Okay, these are equal. So let's use this guy, delta y over delta x, because I'm like confused over the displacement thing. So delta y change is minus 10 over minus 18, and the x coordinate is 32 minus 25. So this would give me minus 28 over 32 minus 25 is 7. So So it would give me a negative gradient, right? Negative value for velocity. Minus 28 divided by 7 should give me 4, I think. So it would give me minus 4 meter per second. So this gradient is minus 4, or the gradient is actually velocity. It is velocity. Okay, so that is how you find instantaneous velocity. If they specify a duration of time, you have to know what is the coordinates. If they ask you about average, you need to know the coordinates for the initial and the final, connect them together, find the gradient of that line. Okay, so that is for your displacement time graph. Okay, kita cover. Okay, what if your displacement time graph looks like this? Do you have any question? Ush, sampai 23 check. Ada soalan ke tak ada? Okay, tak ada soalan Alright, so it's just chatting. So this is your displacement time graph. A different version of it. Tadi kita tengok macam ni, macam projectile motion. This is if the displacement is increasing with time. Okay, it's increasing with time, and the increase is quite uniform. How do you know it's uniform? Because it's a straight line. Therefore, you know that the gradient at this point, M1, is equal to the gradient at this point, M2, is equal to the gradient at this point, and so on. Because it's a straight line, you know that the gradient is the same at all points, because they are basically just M. Okay, so this gradient is uniform. When you have a uniform gradient, it means that you have a uniform velocity. So this gives you M equals to uniform velocity, because the value does not change. The value is the same at all points. Okay, so in uniform velocity, the instantaneous velocity is equal to the average velocity. Kenapa? Because the small section of gradient is equal to the final minus initial gradient. Sama. Average velocity punya values akan sama dengan instantaneous velocity punya value. You can try it yourself. For a straight line like this, you would get the same. Okay, same instantaneous and also average. The instantaneous velocity is equal to the average velocity. A positive gradient means a positive velocity. A negative gradient means a negative velocity. We already know this. Okay. Then moving on. This is a velocity time graph. How do you know it's a velocity? It's labeled V here. This should be labeled. This is time, second. Okay, from this graph, we can know about the instantaneous velocity. We can know the average acceleration. We can also know the distance or displacement. Okay, so for instantaneous velocity, senang. I can just say, let's say this is 10, 20, 30 seconds, 40 seconds, 50 seconds. Contoh, I can say that I can ask that what is the instantaneous velocity at time 30 seconds? At time 30 seconds, what is the V? So just look at this graph, you will immediately know that the V is equal to V final, or let's put a value here, 50 and 30. The instantaneous velocity is 50. Why is it called the instantaneous? Because it is referring to that small duration of time, ataupun the change in time approaches zero applies to the instantaneous velocity. Walaupun saya ambil dekat satu point je, it is considered instantaneous velocity because the change in time approaches zero. That was the definition for instantaneous velocity, right? So even if I take a velocity at one point, it is considered the instantaneous velocity. Kalau tak nak juga macam tu, you can take a small section of time from here to here, you would get around the same value of velocity. Okay, because it doesn't change much over a short duration of time. So basically it's just that value lah. Okay, so that is instantaneous velocity if they ask you from a velocity time graph. And then what about average acceleration? The equation for average acceleration is the change in velocity over the change in time. Specifically for average, kena pakai final and initial position. V final, V initial, T final, T initial. So kat sini dia punya initial and final is P and Q. So you make a line macam biasa. Make a line from P to Q. Kenapa tak boleh? Sekejap. So this is the line and the gradient of the line will give you the average acceleration. The gradient of this line will give you the average acceleration. Tahulah tu gambar gradient susahnya lukis. Okay, so M. Whatever the M that you get, that is equal to your acceleration. The gradient of this line, specifically this line, gives you the average acceleration. Dia tak boleh kalau ambil daripada sini ke sini, that's not average. Average kena total duration from initial to final. That is the definition of average. Connect these two lines together, find the gradient, that is your acceleration from a velocity time graph. Kalau displacement time graph, the gradient is a velocity. From a velocity time graph, the gradient is acceleration. Okay. Let's take a 10-minute break because I am tired. Nanti kita cakap pasal distance and displacement. Okay, if you have any questions, you can ask me. If not, take your break for 10 minutes. Let's come back at 3:10 p.m. Okay? We are almost finished with the subtopic. Kalau ada soalan, boleh tanya.
Doktor, saya nak tanya tentang instantaneous velocity tapi dekat displacement time punya graph.
Okay, gradient is, sekejap gradient is average velocity, average acceleration. Nak tanya instantaneous velocity dekat displacement time graph. Okay.
Yang kira tangent tu macam nak kira dia kita kena buat segitiga ya. Macam contoh dekat point C tu kita kena buat macam segitiga tu
macam dekat point C ni awak punya line ni dia kena touching the point tau. Macam saya cakap. Okay, kejap. So kita nak tahu, contohnya kita nak tahu gradient instantaneous velocity at point C. So bila saya letak line, kan saya letak line macam ni kan. Line ni boleh jadi panjang, boleh jadi pendek. Tapi kalau kita nak letak line ni untuk tentukan kita punya gradient, kita kena letak line dia betul-betul bersentuhan dengan point tu, macam tu. So daripada line ni, cari dia punya segitiga ataupun dia punya gradient, then you will find out the instantaneous velocity. So basically if you find segitiga of this line, it will give you the instantaneous velocity of C. Tak kisah kalau nak buat sebesar-besar alam ataupun sekecil-kecilnya, you will get the same answer because it is referring to the same line. The trick here is the line has to be overlapping that point. Kalau nampak kat sini, dia tak overlap kat tempat lain, dia overlap dekat C. Dia ada overlap dekat D, tapi yang penting dia overlap dekat C macam ni. Okay, another example, let's say E. E ni macam ada lekuk sikit kan. Okay, how do we draw the line? Okay, let me use a big line macam tadi. Let's use tebal sikit this time. Let's use yellow. Okay, I want to know the gradient at point E. So I have to make a line, tapi line tu dia kena touch point E macam ni. Dia kena betul-betul touch. So as you can see here, lebih kurang lah dengan yang line green ni kan. So whatever value that you get from this line, whatever the gradient that you get, that will be your instantaneous velocity. Walaupun dia besar, gedabak macam ni. Asalkan dia touching that point betul-betul. Okay, is that clear?
Clear, dah clear.
Okay. This line is called a line that is tangent to the point. I'm just going to introduce this to you. The line drawn should be tangent to the point, to the what do you call this? To the specified point lah. Tangent nama dia, tangent. Dia bersentuh macam tu. Dia tangent lah nama dia. Memang nama dia tangent. Kalau korang baca internet kat Google ke apa ke, kalau dia cakap tangent, this is what it means. Doktor jawab soalan. Okay. Ya. Yeah. Ada 4 minit lagi untuk rehat. Doktor, yang ni kalau gradient dia velocity, betul? Kalau time displacement time graph, gradient dia adalah velocity. Macam mana nak tahu? Equation. So velocity equation dia change in displacement over the change in time. Yang ni adalah change in displacement over the change in time. So you get velocity from this graph. Macam mana koordinat pun boleh gunakan doktor untuk cari gradient. Okay, untuk average wajib pakai final and initial coordinate. Untuk instantaneous velocity, you have to draw the line and kat mana-mana point nak pakai boleh. Tapi line tu mesti touching the point that they ask. Boleh pakai mana-mana point tapi dalam line yang kita lukis tadi tu. Okay. Untuk instantaneous ada banyak jawapan. Betul. So kalau tengok kat sini B, C, D, E, F akan ada jawapan yang berbeza-beza sebab dia punya gradient pun berbeza-beza. So you get different instantaneous velocities. Average je yang ada satu. Okay. Terlebih masa pula saya berehat. Okay, I hope everyone is back from toilet, whatever, snacking ke apa ke. Okay, now we're talking about the velocity time graph. Tapi tadi saya ada very good questions from your classmates, so I'm going to go over that a little bit. So just now, the question was, mana? The question was, would we have a lot of different instantaneous velocities for this graph? Okay, I'm going to repeat the question. Would we have different instantaneous velocities? Would we have different instantaneous velocities for this graph? The answer is yes, because kalau tengok kat sini kita ada different tangent, kita ada different gradient for point B, kita ada different gradient for point C, a different gradient for point D, different gradient for point E, different gradient for point F. These are all instantaneous velocity. Therefore, you would have different velocities, different instantaneous velocities for different duration of time. For different durations of time. Okay. Ni untuk specifically untuk masa 9 ke 12. Yang ni specifically untuk masa 18 ke 22. Ni specifically untuk masa 28 ke 32. Contoh So you would have different instantaneous velocity depending on the time. Okay. So it depends on which time they are asking you for. Kalau diorang tanya daripada masa sini ke sini, then you would find the instantaneous velocity at point D. And then there was another question. How should we draw the line? Gambar, kenapa yang ni hilang? Oh, tak hilang. How should we draw the line to find instantaneous velocity? So my answer is the line should be drawn tangent to the specified point. So tengok kat sini, saya letak as line kuning. Line kuning Line kuning ni, line kuning ni panjang gila. Tapi saya nak tahu what is the gradient for point C. So how should I put this line? I should make it overlap exactly on point C. Point C je yang saya concern sekarang ni because I'm finding the instantaneous velocity for point C. So tak kisah panjang ke pendek ke, tak kisah panjang ke pendek ke, asalkan point dia bersentuhan dengan C. Bila line tu bersentuh dengan C, or when the line touches the point C, this is called tangential to the point C. The line is tangential to the point C. This is what it means. The line is tangential, maksudnya dia bersentuh tapi dia line lah. I don't know how to say this in any other explanation. So what if I'm concerned about point D? Would this line serve me? No, it would not. Okay, jap. Sebelum saya pergi ke point D, macam mana nak cari gradient dia? I can find the gradient for the entire line, or I can find a small gradient for this short line. Boleh. Because it will basically give me the same answer. The line is the same for all points, and it specifically specifies the gradient for point C. Okay, I'm going to repeat myself. So I put the yellow line tangential to the point C. Gradient yang saya dapat, the gradient that I get from this yellow line would give me the instantaneous velocity at point C. Walaupun besar gedabak terkeluar dari C, it still gives me instantaneous velocity at point C. Kenapa? Because this is the same line. It extends. This is just an extension of that line. So it gives me the same gradient. Therefore, it gives me the same value lah. Okay, so what if I want to know what is the instantaneous velocity for point D? Can I use the same line? The answer is no. Kalau tengok sini betul-betul the yellow line is not tangential to D. It's not. It's not touching the point D. So kalau saya nak buat untuk D, it has to be a different line. So let's say this line, kita buat warna lain lah format shape, let's make this guy red. Okay, so I want to make this line tangential to point D. Make it tangential, it has to be touching and bersentuh dengan graf ni. Tapi dia bersentuh dengan graf ni dekat point D. So dia kena bersentuh dengan graf and dekat point D. So dia macam ni rupa dia. Okay, alamak tak nampak. Tukar colour jap. Colour apa yang nampak? biru. Tak nampak juga. Kang pakai putih Kang. Kejap. Warna apa yang nampak ni? Tak nampak lah. Hitam. Hitam. Okey, hitam nampak. So this is the line that is tangential to the graph and point D. Dia kena bersentuh dengan graph dan bersentuh dengan point D. Memanglah saya cakap bersentuh dengan point D kan, tapi bersentuh dengan point D tu pun kenalah dengan graph. Contohnya line hitam ni awak boleh cakap, okay doktor cakap kena bersentuh dengan point D. So awak letak macam ni. Salah lah, kena bersentuh dengan graph Kena bersentuh dengan graph. Tangential to point D meaning to say to the graph. Okay, because point D is at the graph. So macam tu rupa dia. So kalau saya nak panjang lagi boleh. Panjang lagi, nak lagi panjang daripada tu boleh. Sebab basically whatever gradient that I get from this line will give me the gradient of D. Tak kisahlah sebesar alam ataupun sekecil-kecilnya, you will get the instantaneous velocity at point D. Okay, sama juga kat point F. Kita tengok kat sini, point F dia letak macam ni, kecil je. Kalau saya nak buat kecil macam ni pun boleh. Sini ke sini, boleh. Saya nak buat panjang macam ni pun boleh. Asalkan tangential to point F. And then basically V equals 0 lah. Okay, because it is displacement. And then another question is, Doctor, why do we get velocity from this displacement time graph? Why do we get velocity from this displacement time graph? Okay, itu bukanlah soalan yang sebenar. Saya ulas sikit. So why do we get velocity from our displacement time graph? Because velocity is the change in displacement over the change in time. When we calculate for the gradient, we are finding the change in displacement over the change in time. Kan? Bila kita cari gradient, kita cari change in displacement over the change in time. Therefore, we get velocity. So from a displacement time graph, the gradient gives us velocity. Okay? So ada soalan lain ke? Tak ada.
Doktor, nak tanya.
Yes?
Contohlah kan kalau dia suruh cari instantaneous velocity untuk any point, contohlah any point C kan. Nanti jawapan dia akan slightly different ke setiap orang?
Should be approximately the same.
Sebab kalau kita garis kan kena buat garisan sendiri kan doktor? Tak ke macam dia macam line sikit untuk tak garisan tu.
Lain sikit lah, tapi it should be roughly the same lah. Kalau awak dapat 10 tapi Haikal dapat 12, memang salah lah, tu jauh sangat. Kalau awak dapat 10, Haikal dapat 10.1, acceptable. Dia kena roughly the same. Okay?
So kalau dalam jawapan dia bagi range lah untuk jawapan tu.
Untuk exam yes. Ada range dia, tapi selalunya saya akan tengok jalan kira. Kalau saya tengok jalan kira betul, saya accept je. Tak ada range pun. So jangan risau.
Okay, thank you.
Jangan risau sangat pasal range. Just show me your working steps. Okay?
Okay, thank you doktor.
Okay, so those are the questions that was asked. Ada soalan lain lagi ke? Haikal, sorry Haikal pakai nama awak sekejap. Okay, tak ada dah soalan. Okay, let's move on to this one. Kita cakap pasal velocity time graph. And like I mentioned to you before, a velocity time graph will give us acceleration. Kenapa? Because basically when we talked about the gradient of the graph, we are talking about the change in V over the change in time. So change in V over the change in time will give me acceleration. If I find from the final to the initial point, this line will give me the average acceleration. Delta V over delta T will give me the average acceleration. Kalau nak tahu instantaneous acceleration, sama juga. Let's say we want to know what is the instantaneous velocity, instantaneous acceleration at this point. So again, use your ruler or your line. Make a line that is tangential to the point that we want. In this case, that is our line. So the gradient, purple tak ada lah. Tadi ada request untuk purple kan? Tak ada. Ada tak purple kat sini? Okay, purple. Okay lah, boleh lah. So this is the line that is tangential to our pink point over here. So gradient of that line would give you the instantaneous acceleration of point A, contoh point A. Okay, acceleration at point A. So carilah gradient line ni, you would get a positive value sebab dia ke atas. Sama juga kalau nak cari instantaneous acceleration over here, make a line, whatever the gradient that you get, that is your instantaneous acceleration at point Q. Sama je. And then the displacement. How do you calculate the displacement from a velocity time graph? It is the area under the curve. So macam mana tu? So area under the curve, kita ambil contoh yang senang sikit. Let's say you have your velocity time graph like this and your velocity is like that. This is your V and this is your T. Your graph is like this and the area under your curve, you should take the area up to 0, 0 point. Sorry, up to 0. Dekat sini lah, basically the y-axis is your penghadang. Okay, so you should take the area up to the x-axis. Let's say your V is, at this point is 10 and the time at this point is 5. So the area for this guy is 1 over 2 times 10 times 5 because it's a triangle. The area is a triangle, right? So displacement x is equal to 5 times 5 is 25. Oh. Undo. Kenapa ni? Sekejap eh. Boleh pun. Okay, so the area under the curve is your displacement. Cari je area macam biasa. And this is 10, this is 5, it's a triangle, so divided by 2. So this is 5, 5 times 5 is 25. And the unit is, kat sini apa yang kita darab kat sini? Kita darab 10 meter per second, darab dengan 5 seconds. So second cancel out with second, you are left with 25 meters. That's your displacement. This is for a relatively easy graph lah sebab kita tahu it looks like a triangle. What if we have a curve like this, right? How do we solve the displacement for a curve? So it gets slightly difficult, but not impossible. So what do? We just kita akan pecah-pecahkan dia ikut shapes. So kat sini contohnya, kat sini rupa dia macam triangle. So cari area triangle. Kat sini cari apa panggil shape ni? Saya tak tahulah. So cari area yang ni. And then maybe this is a square. Cari area sini. And whatever this shape is, cari area sini. And this guy, cari area sini. So the total area of these blocks A, B, C, D, E, semua ni, that is your displacement. The total area gives you the displacement. Kena cari sampai x-axis tau. Cari x-axis. Assuming that it starts from 0, 0. Okay. I have a lot of chats here. Let me see. Macam at maths. Saya tahulah, saya at maths pun saya tak berapa nak score. Modern maths. I think it's modern maths kot. Tak tahulah. Okay, trapezium trapezium. Bukan guna area under the curve doktor. This is area under the curve. Maksud Amy apa? Was it before I specified this whole rectangle? Integration. Yes, it's integration actually. Betul. Oh, integration ni lah kan, at maths lah kan? Yep, betul. Bahagian curve tu. Yes. So the integration of this curve, or basically the area under this curve, is your displacement, because differentiation gives us the gradient. This is differentiation, and the area under the curve is integration. Kalau nak relate back lah. Kalau tak ingat, tak payahlah. Okay, so it gives us displacement x. So again, I'm going to repeat myself. Displacement is area under the curve. This includes yang bawah ni. Walaupun nampak macam bukan part of the curve, but basically it is part of the curve. Sampai bawah sini. Sampai bawah. Okay, kena include. Okay, ada lagi tak? Alright, so that is it. Okay, so linear motion with uniform positive velocity. So we know that our linear kinematic equation is V equals to U plus AT. And we said that if our velocity does not change, it means that our acceleration is 0, right? So a velocity that does not change looks like this in a velocity time graph. So the U, this is U, and the V is equal. Okay, therefore acceleration is equal to 0. Therefore, your V equals to U plus AT equation becomes V equals to U. Saja je lah nak tunjuk in terms of graph. Kalau, but if our A is 0, kita tengah cakap pasal A equals to 0 sekarang ni. If our A is 0, what about the displacement graph, right? So for our displacement graph, it's basically the linear kinematic as well, S equals to UT plus 1 over 2 AT squared. The 1 over 2 AT squared component becomes 0. 1 over 2 AT squared, yang ni jadi kosong. So basically your S is just U times T. Kat sini your U is 1.3 maybe. So 1.3 times time. So S equals to UT. 1.3 times time. So let's say this is 1. This is 2, 3, 4, 5, 6, 7, 8, 9. This is 9. 1, 2, 3, 4, 5. This is 5. So let's kita cari dekat point 1, point 5 and point 9 So 1.3 times 1, 1.3. And then 1.3 times 5, I don't know. And then 1.3 times 9. So let's see. Kita pakai equation ni bila kita buat graph sebenarnya. So this is S at 1, this is S at 5, this is S at 9. So 1.3 times 5, 6.5. And then 1.3 times 9, you get 11.7. Sorry tak kat sini. So this would be 11.7. Dekat time equals to 5 would be 6.5. And at time 1 would be equal to 1.3. So this is how you use the graph to plot. Sorry, this is how you use the equation to plot your graph. Okay, so semua ni berkait dengan equations and also differentiation, integration, semua ni berkait. It should make sense. Kalau ada benda yang tak make sense, then you need to read further ataupun cuba fahamkan lagi lah. Okay, so this is if our acceleration is equal to 0 in the velocity time graph, we get a straight line because velocity does not change. In the displacement time graph, we get a straight line with a positive gradient. Okay, this is also assuming positive V. Okay, kalau negative V ke bawah lah. Okay, so this is V equals to minus U. So sekarang ni it's saying that V is equal to U, tapi it's a negative value. So it's still a straight line. This is referring to A equals to 0. The S is also a straight line yang ke bawah. Gradient is negative. Okay, negative gradient. Ataupun negative V. Sebab V kita pun negatif kat sini kan. Minus 0.7. So S equals to minus 0.7 times time. So you can plot your displacement time graph using this equation. This is assuming A equals to 0. Okay. Next, what if our A is not equal to 0? Let's say our A is not equal to 0 and it is a positive value. So if our acceleration is a positive value, remember our velocity should be increasing positively sebab acceleration 0 kan. So this is A positive ataupun gradient dia kena positive. And in terms of displacement, it follows the S equals to UT plus 1 over 2 AT squared. This is a parabolic equation or a quadratic equation. Dia ada kuasa 2. Kuasa 2 rupa dia parabola and it looks like this. Okay, dia smiling face. So that is your displacement equation. Kenapa dia rupa dia parabola? Sebab dia ada kuasa 2. Kuasa 2 memang ada curve-curve sikit lah. kat sini ada satu kuasa je. Satu kuasa dia rupa dia straight line. Kalau tak ada kuasa langsung, V equals to U plus AT kuasa kosong. Maksudnya tak ada kuasa lah, basically V equals to U kan. It was a straight line, right? This is what we saw just now. Okay, ni tak ada kuasa. Kuasa 1, kuasa 2. Kuasa kosong. Okay, and then what if our A is negative? Sama je, now it's a negative gradient. And now a parabolic equation is below the x-axis ataupun below it's in the negative displacement and is a sad phase. This is for negative A. Okay, so kalau positive A dia gembira. Alright, penatnya. Okay, so now we go into examples. Yay, so dia boleh berehat sikit. So basically what can they ask you with this subtopic, right? They can ask you to describe the motion. So let's see, kalau motion kita daripada kosong ke T1, the velocity is increasing, the acceleration is positive. We can say that. And from T1 to T2, the velocity is constant. Therefore acceleration is 0. You can say that about the motion. From T2 to T3, the gradient is negative. Therefore, the velocity is negative. The acceleration is also negative. And then total displacement, calculate the area. Ni total displacement. Kalau dia tanya find the displacement between T1 and T2, then you only find the area between, it's T1 to T2. Then you only find the area of this box, T1 to T2. Okay, so these are the possible questions on this subtopic. Apa lagi? Okay, from a displacement time graph, they ask you what is the velocity at time T3. So kena tahu the velocity at this time, use your line gradient. Ini yang kita dah belajar tadi, instantaneous velocity, right? Because it is referring to a specific duration of time or a single time. So that is referring to instantaneous velocity. Kalau tanya pasal average velocity between T2 and T5, mana T5 nya? Tak wujud kat sini. So let's say it's asking T1 to T3 punya average velocity. So this is T1 and this is T3. Make a line. Cari gradient. That is your average velocity. What is the total displacement? Cari area. No. You have to... Bukan. Displacement time graph bukan cari area. You have to add. So from T1, 0 to T1, the displacement is 5. From T1 to T2, the displacement is 0. Sebab tak ada perubahan. From here to here is minus 10. So the total displacement is minus 5. Yang ni kena kira, tak apalah, nanti kita buat example. Okay, so for a displacement time graph, you cannot use the area to find the displacement. But for a velocity time graph, you can. Cari displacement. Okay, X is equal to V, change in V over change in T. Ataupun V equals to change in X over change in T. If you put this over here, it becomes X equals to V, change of V, change of T. Okay, semua ni berkait. Okay. Alright, so we have an example. Yay. Okay, I'm going to give you guys 7 minutes to do example 2.7. Sekejap. Do you have time? Yes. Let's do example 2.7. Sekejap, mana yang lagi susah? Find the instantaneous velocity of a particle. Okay, ni senang. So let's do this together. Example 2.7 and 2.8. Dia suruh cari instantaneous velocity je. Senang. And graph dia pun senang. Let's do this in 10 minutes. Saya akan panggil macam biasa. Now it's 3:35, 3:45. Okay. So these two examples korang buat and then there is another example yang ni saya akan discuss sendiri. Yang ni panjang. So ini kita discuss sama-sama. Yang ni korang buat sebab ini senang. Sepatutnya lah. Okay, nak panggil nama siapa? Let's see. Amy tanya doktor velocity at T3 tu instantaneous ke? Tapi dia sama je kan dengan V equals to T2 minus T3. Yes, betul. Yeah. Okay. Salam. Okay, so Amy tengah cakap pasal example yang saya cakap tadi. Nanti saya cerita balik. Buat dulu soalan, okay? Okay. Yeah. B is for be quiet. Okay, untuk example 2.7, Nazihah for A, B is Lukman, C is Kasih, D is Molly. Untuk example 2.8, Soh buat A number 1 and 2. A is number 1 0 to 5 second and number 2 is 5 to 15. Safa buat 0 to 20. Feli buat instantaneous acceleration at 10 seconds and Atira buat instantaneous acceleration at 18 seconds. Okay, thank you. Okay, it's 1 minute to go. So hopefully example 2.7 punya volunteers dah ready. Dengan harapan korang volunteer secara sukarela lah. Okay, Naziha dah ready ke?
Dah, tapi saya tak sure jawapan saya betul ke tak.
Okay, tak apa. As usual, salah tak apa. Kita discuss sama-sama. Okay, so what did you do to find for A?
Saya tengok dia punya displacement dekat time 0.5 is 2. So lepas tu saya bahagi dengan 0.5.
Displacement 2 bahagi dengan 0.5. Okay, so 2 divided by 0.5. Sekejap. So basically awak tak buat line lah.
Tak, sebab saya tak tahu nak buat line macam mana sebab graph dia pun dah macam straight line
Okay.
instead of a curve.
Okay, okay, tak apa. So kalau kita nak bayangkan line yang Naziha tak buat tu, it is basically on top of the plot itself, tak ada tangent. So basically the line is basically the line itself. The plot itself, sorry. The line is basically the plot itself. So kan gradient untuk benda Allah ni sama dengan gradient untuk instantaneous velocity at point 0.5. So jawapan Naziha betul walaupun dia tak sure. So it's correct. Okay, next one. Luqman, are you ready?
Saya pun tak pasti sangat dah doktor.
Okay.
Saya buat cara sama je. Saya buat cara sama dengan Naziha. So saya buat dia punya X dia 2. So Y dia kosong. So saya kosong bagi 2 dapat juga kosong. So dia punya velocity dia kosong.
Sekejap, 2 bagi kosong.
Terbalik.
Kosong.
Betul tak?
2 bagi kosong infinity.
Kosong bagi 2. Sebab Y over X kan. So Y dia kosong, X dia 2.
Okay. Macam mana Kasih buat? Kita tengok dulu.
So saya dapat kosong.
Okay, sorry. Kosong. Nak juga kosong tu. Fine. Kosong. Okay, C. Kasih. Kasih buat macam mana?
Hello, dengar tak doktor?
Dengar.
Saya pun tak pasti sebab garis dia lurus. So gradient dia kosong ke?
Okay, kalau gradient dia kosong macam mana cara kira dia?
Tapi saya buat yang macam Luqman dengan Naziha punya. Negatif tu bahagi 3. No, 0.
Okay. Bahagi berapa tu?
Itu bahagi 3 kan?
Bahagi 3 sebab awak time 3 second. Okay. Okay, D macam mana D? Harapnya Molly penyelamat kita. Please selamatkan kita Molly. D buat
Saya kosong tolak negatif 2 over 5 tolak 4.
Okay, Molly punya soalan
Kosong tolak negatif 2.
Tolak negatif 2.
Kosong tolak negatif 2.
Okay, sorry. Saya tak tersilap tadi. Alright. So kosong tolak negatif 2, 5 tolak 4. So Molly punya soalan
Equals to 2.
Equals to 2. Okay, thank you Molly. So Molly punya soalan is 4.5 seconds. Dia suruh cari instantaneous velocity kan. So kalau kita letak line tu basically the same line as this gradient over here. So Molly pakai gradient of this line and untuk time dia 5 tolak 4. Okay, yang ni 5. Lepas tu yang ni kosong. Kat yang ni point, ini this point Macam mana saya nak tunjuk? Okay, saya tulis balik sorry. So this is 5, 0. This is the coordinate. And this is the coordinate minus, it's 4 minus 2. Okay, so the change in y is 0 minus 2. The change in x is 5 minus 4. And the answer is 2. And the gradient should be positive. So betul. Molly punya jawapan sahaja yang betul. Orang lain tak betul Ya Allah. Korang tak faham lagi ni. Okay. So how should we do A, B, C? Okay, so Naziha jawapan dia betul. Tapi cara dia kira tu kurang tepat. Okay, again. use the line that is already in the plot. So instantaneous, kalau kita nak cakap pasal instantaneous dekat time equals to 0.5. Okay, kita nak tahu instantaneous dekat time 0.5. This is 0.5. So basically kita nak tahu gradient kat sini. Gradient kat sini kalau kita extend, dia sama macam line ni. So saya sebenarnya boleh cari gradient of this entire triangle. So gradient of this guy would be 4 minus 0. Is it? Yeah, 4 minus 0 over 1 minus 0. So my equation should be 4 minus 0 over 1 minus 0. Get 4 meter per second. Jawapan Nazihah betul, tapi cara kira dia salah. Okay, so lucky. Nazihah was lucky. Okay, for B, nak revise balik tak? Siapa? Luqman, nak revise balik tak? What should...
Doktor,
Yeah.
kena saya try guna yang apa garis lulus ni kan. So saya guna titik 1 dengan 4 dengan 25 dengan negatif 2. Macam tu kan doktor?
Negatif. Okay, apa equation awak?
Equation saya tolak 25 negatif 2.5
Negatif 2.5
minus 4 over 2.5 minus 1.
2.5 minus 1. Okay, jawapan dia?
Saya dapat negatif 3.6.
Okay, tengok Thank you Luqman. So negative 2.5 is down here. 2.5. Okay. Awak ambil bawah ke sini Okay, tak apa. Kenapa awak ambil bawah daripada negatif 2.5? Okay, tak apalah.
Doktor, terbalik. Terbalik, Allah.
Okay, macam mana awak buat?
Dia punya negatif tu Y bukan salah pula bagi.
Okay, so ni saya rasa ni negatif 2 lah. Kan?
Ya, negatif 2.
Negatif 2 tolak dengan positif 4. Yang ni time dia 2.5 tolak dengan masa 1. Make sense. So 2 tolak 4 minus 6 bahagi dengan 1.5. 4 ke jawapan dia? Minus 4 ke? Minus 6 divided.
Yes, minus 4.
Okay, minus 4. Okay, rasanya orang lain dah faham ke cara nak buat ni? Okay, C pula. C macam mana tadi? Siapa yang nak kena revise tu kasih. Please revise your answer. Macam mana awak nak buat?
3 tolak 3 ke?
3 tolak. Awak kat sini kan? Okay. Y axis awak apa? Minus 2, right? Minus 2 minus 2. Minus 2 minus 2 over 4 minus 2.5. Okay, so kat sini kasih ambil dari sini minus 2 tolak minus 2, 4 tolak 2.5. Saya lukis balik. So this is the gradient that Kasih is using. So daripada 4 ke 2.5, daripada 2 ke minus 2. So minus 2 minus 2 over 4 minus 2.5. Jawapan dia kosong. Jawapan kosong tadi dah betul, tapi dia tak tahu macam mana dapatkan kosong tu. Okay, so Molly je yang berjaya. Okay, good job Molly. The rest of you yang berjaya revise pun good job. Hopefully lepas ni tak salah dah. Okay. Any questions about this one? Faham ke kenapa kita buat macam ni? Faham ke? Ke tak faham? Okay, saya cerita balik So tadi soalan ni dia tanya instantaneous velocity of a particle at point 0.5. So kalau kita guna balik cara line that is tangential to the point that we are interested is at time equals to 0.5. This is the point that we are interested in. I make a line. Pakai line. Kalau tak nak pakai line, pakai je graph. But in this case, saya nak tunjuk korang. So saya pakai line. So line yang tangential to the point that I'm interested in must also overlap with the graph. It gives me, Allah, dia tak center pula. It gives me the same line as the graph. So basically, I just find the gradient of this graph at this point. So jalan kira pun kena betul lah. So cara nak cari gradient of this line is I need to know the coordinates. So the coordinate is 0.5, 4, and at this point is 0, 0. So jawapan dia 4 tolak kosong. Oh, kat sini dia pakai 1. Boleh, pakai 1 pun boleh. Kenapa pakai 1 Oh, kat sini 1, sorry. Betul lah 1, bukan 0.5. Oh, pelik pula. Kat sini 1 So 1. So 1 tolak kosong. Macam mana? Final tolak initial. Final y-axis tolak initial x-axis. Sorry. Final y-axis tolak initial y-axis. Final x-axis tolak initial x-axis. Gives you the gradient of the instantaneous velocity at this point. Semua juga macam yang lain. At 2 second and 3 second. Saya nak tahu dekat point sini. And also saya nak tahu dekat point sini. And saya nak tahu dekat point sini. So saya pakai line graph lagi. Pakai line and cari gradient. So kalau saya nak pakai line, line tu akan extend dari sini ke sini. Ataupun cari je lah gradient untuk keseluruhan triangle ni. Okay, so this is what Luqman did. Kat sini pula, pakai line sini. Line kat sini dia -2 to -2 untuk y-axis, 4 ke 2.5 untuk x-axis. So 4 tolak 2.5. Oh, what happened? Go away. Okay. 4.2.5 atas ni -2 -2. So you get a 0. Okay, Molly did. Dia cari daripada sini ke sini. Dia cari for the entire triangle. 0 -2. 5 tolak 4. This is what Molly did. Okay, so hopefully semua orang faham dah macam mana nak guna graph untuk kira instantaneous velocity. Okay, example 2.8. Let's do this. So.
The ways that I do is I use velocity 2 minus velocity 1 per t2 minus t1.
Okay.
The velocity 2 coordinate is the x value is 5, the y value is -8.
5 and -8, okay.
And the v1 is cos 0 and -8.
0 and minus. Sorry, saya terlalu sekejap.
Yeah, I think.
This is 0 and -8, and this guy is 28. Okay. So these are the coordinates, and your answer A is.
Doctor, the A is 0 second to 5 second.
The A is 0 second
to 5 second.
Oh, sorry, sorry.
Yeah.
This is 5 minus 8, right?
Yeah.
Okay.
So I take my -8 minus -8.
Okay, -8 minus -8. Minus ke minus?
Yeah, minus.
Okay.
Sorry.
All right. What about the time?
5 minus 0.
Basically, you are finding the line between here to here, right?
Yeah.
Line. Okay. So your answer is?
So 0 ms per 0 ms -2.
ms 0 ms -2. Oh, okay, 0 lah.
Yeah. Okay, yeah. Okay. Thank you.
What about your number 2? Okay, number 2. So, let me write this here. So betul lah, acceleration is the gradient for a velocity time graph, and the acceleration here is 0 because it's a straight line. So well done. So number 2, so juga kan? So dia kena buat number 2 juga. 5 to 15. Hello, so. So dah hilang dah. Ke saya yang pada internet?
Sorry, I didn't open the mic. Sorry, teacher. Sorry, doctor.
Alright, no problem. So what
Okay, so the coordinate for 5 seconds is 5, -8. So the 15 one is 15, 8.
Okay.
Yeah. So the calculation is 8 minus -8.
Oh, 8 minus -8. Okay.
Yeah, and then bahagi 15 tolak 5.
Okay, so your answer is
16 per 10.
1.6.
Yeah, correct.
Okay,
10.6. Yeah. Thank you. Sorry.
So no problem. Okay, so got the average acceleration of this object during the time interval of 0 to 5. So 0 to 5 dia nak cari average acceleration untuk line ni sahaja. That is the question. So 0 to 5. So found the line. He specified the coordinates. Final tolak initial, and he got the answer at 0. Betul. And then for B, 5 to 15 seconds, I'm expecting a positive gradient, and he specified the coordinates before putting it into the equation, and dia terus pakai change in the y-axis 8 minus 8, 15 minus 5. So he got 1.6. Betul, positive. And then Safa, number 3. Safa. Ada soalan?
Okay, for number
Okay, boleh. Yes, number 3.
Number 3 point apa ni? Initial point is 0, -8, and the final point is 28.
Okay.
That one. Lepas tu untuk cari average velocity dia, final velocity minus initial velocity, which is A minus -8 over final time minus initial time, which is 20 minus 0.
Okay.
So I got 0.8 meter per second square.
Okay. Any velocity ke acceleration?
Apa?
What are you trying to find? Average
acceleration.
Okay, thank you, Safa. Next is Feli and Atira. Teratur saya tulis, sorry. So Feli, how did you do for 3? B.
For the instantaneous acceleration, I use 8 minus -8 divided by 15 minus 5.
15 minus?
We will get 1.6 meter per second square.
Okay, so basically jawapan Feli sama dengan jawapan Soh for number 2. This guy, right? Jawapan dia sama. Sebab apa 5 to 15, the average acceleration is equal to the instantaneous acceleration at this point because they have the same line, they have the same gradient. Therefore, the instantaneous acceleration at time 10 seconds is equal to the average acceleration between time 5 to time 15. Okay, faham They are the same line, therefore they have the same m. Okay, all right. So number B for 18 seconds, I think is Atira.
Doktor.
Yes.
Sekarang dah pukul 4:03. Kita orang ada kelas English.
Okay, sorry. So okay, I assume korang boleh buat sendiri lah the last one. Okay, bye korang, bye. Sorry, terlebih masa.
Tak apa doktor, tak apa.
Thank you, doktor.
Thank you, doktor.
Dengan doktor nanti dah tak ada dah.
Thank you, doktor.
Bye-bye, sorry terlebih masa.
Tak apa.
Welcome, bye-bye.
Thanks, bye-bye.